Beyond Neptune lies a dark, icy void where a vast and mysterious region floats. This area holds ancient fragments left over from the birth of our solar system, drifting silently in the deep, cold universe like frozen time capsules, perfectly preserved. To get there from Earth, we'd need to travel through the inner solar system, passing Mars, then soaring beyond Jupiter and Saturn with their swirling storm clouds. After that, we'd cross the blue giants Uranus and Neptune, before finally reaching this icy frontier. Welcome to the Kuiper Belt, a massive ring of frozen debris, like a glowing halo stuck in the darkness, circling the entire solar system. But this region is more than just floating space rocks. It's a time capsule from 4.6 billion years ago. Holding the original materials that built our solar system, it's home to dwarf planets and strange objects that even puzzle scientists. Today, let's dive into this shadowy edge of the solar system and search for clues about how planets formed, where comets come from, and whether the seeds of life might be hidden here. Before the Kuiper Belt was confirmed, scientists suspected something existed beyond Neptune. For decades, Pluto was thought to be the lone member at the solar system's edge, but it was too small and its orbit was odd, making astronomers wonder if it was part of something bigger. In 1951, an astronomer named Kuiper suggested there might be a ring of icy material beyond Neptune. Back then, telescopes weren't strong enough to prove it, so the idea sat dormant for years. Then, in 1992, two scientists discovered the first true Kuiper Belt object, and everything changed. Although Pluto and its moon Charon had been found decades earlier, it was only then that they were recognized as part of this family. Since then, more and more Kuiper Belt objects have been spotted, revealing the true shape of this once blurry region. Starting from the Sun, we pass Mercury, Venus, Earth, and Mars, then reach the asteroid belt between Mars and Jupiter. This belt is full of rocky leftovers from the solar system's early days, about 2.2 to 3.2 astronomical units from the Sun, AU. Being the distance from Earth to the Sun, the belt is roughly 1 wide and contains asteroids of all sizes, from the biggest series, over 500 kilometers across, to tiny chunks just tens of kilometers wide. Even so, if you added up all their mass, it'd be less than 3% of the Moon's. Moving outward, we enter the realm of the four giant planets: Jupiter, Saturn, Uranus, and Neptune. These massive worlds dominate the outer solar system. Finally, beyond Neptune's orbit at 30 astronomical units, we arrive at the Kuiper Belt, stretching from 30 to 50 astronomical units. It's filled with all kinds of objects. Frozen relics from the solar system's start, dwarf planets like Pluto, Eris, Haumea, and Makemake, and countless smaller icy bodies. Like the asteroid belt, the Kuiper Belt is a warehouse of ancient fragments. These objects come from the solar nebula before planets formed, the raw building blocks of the universe. They could have become a new planet, but Neptune's strong gravity kept them scattered. Unlike the rocky asteroid belt, the Kuiper Belt is mostly ice methane ammonia and water ice, making it like a giant frozen donut at the solar system's edge. Scientists estimate it holds tens of thousands of icy objects over 100 kilometers wide, over 10,000 comets, and tons of smaller bits and dust. The average distance between them is about 0.02 to 0.1 astronomical units, or millions of kilometers. Beyond the main belt lies the scattered disk, reaching nearly 1,000 astronomical units, with some orbits stretching even farther. Then there's the Oort cloud, an even bigger, more mysterious structure, spherical shell of icy bodies surrounding the solar system, too far for telescopes to see. It stretches from 2000 to 100. 0O. The Kuiper belt is a flat ring, while the Oort cloud is a round bubble. Despite their differences, both are comet factories. The Oort cloud produces long-period comets that take thousands of years to orbit, while the Kuiper belt spawns short-period ones. Today's Kuiper belt is just a shadow of what it once was. Early in the solar system's history, it might have held 7 to 10 Earths worth of material, but as the giant planet shifted, much of it was flung out, eaten up or smashed apart, leaving less than a tenth of an Earth's mass. Its still shrinking collisions create dust and fragments, some blown away by solar wind, others pulled toward the sun to become short-period comets. Famous ones, like Halley's Comet, which returns every 76 years, come from here. Another, in 1994, crashed into Jupiter the first time we saw two solar system bodies collide. A stunning cosmic car crash. We've even visited the Kuiper belt. The New Horizons probe, the only spacecraft to reach it, flew past Pluto and then a strange object called 2014 Mu-69, later named Arakoth, meaning sky in a Native American language. In 2019, it got within 3,500 kilometers of Arakoth, 1.5 billion kilometers beyond. Pluto, the farthest close-up mission ever. Arakoth, a contact binary formed by two objects gently merging. Looks like a flattened snowman. Its smooth surface suggests it formed slowly, not from violent crashes, helping settle a big debate about how small planets begin. New Horizons also gave us Pluto's clearest pictures, including its famous heart-shaped region, Tombor Regio. This isn't a drawing or crater, it's a real icy feature, with a huge nitrogen ice glacier called Sputnik Planitia. Scientists think a subsurface ocean or a slow angled impact might have shaped it. Pluto's moon Charon showed a giant crack, possibly from a frozen ocean too. Will we explore more? New Horizons might leave the Kuiper belt, and could get a new target if NASA finds one. Future telescopes like James Webb might study these objects' makeup. And one day robots could land there, bringing samples back